From the beginning of time, mankind has been tormented with the same primordial questions. Where do we come from? Where are we going? What is the origin of the universe? The cavemen, in their limited time for wonder and intellectual exploration, probably just asked themselves if there was a better way for them to gather food and keep themselves alive. After a while, they probably noticed that some of their relatives were not feeling very good and wondered how to make them feel better. In our society, these questions are still being asked. We look further than ever before into space, and we also take the best care of our sick we have ever taken. So in the middle of these activities, there is a very active science, helping develop both endeavors to formally unthinked of frontiers. Physics. Sure, it helps us develop better telescopes and to understand what we see through them. But how is it helping make sick people feel better? To answer this question, we have to look at one of the most sophisticated yet biggest machine man has ever created, the Large Hadron Collider, a particle accelerator. Cancer patients, theoretical physicists, and wine tasters can benefit from these machines, whose function is as simple as the name suggests: accelerate particles of several kinds, from tiny electrons to heavy alpha particles, in order to kill cancerogenic cells, analyze the inner structure of matter, or devise the optimal arrangement of the molecules in a good wine. What is the problem then with these wonderful machines? As usual, the apparent cause and solution to most problems on these days is money. Particle accelerators are expensive to build, difficult to plan, and even more expensive to operate, since most employees around them have at least a PhD or an MD when it is used in a medical facility. Small particle accelerators formerly used for physics research can be readapted into medical particle accelerators with a few minor adjustments into the frequency and power of the rays. The very big particle accelerators, such as the LHC and the Tevatron, were billion-dollar projects which have provided new insights into the most minuscule parts of creation while pushing technology forward. But they were not conceived without difficulty. The money invested in these big projects is often fogged by other science disciplines who believe more can be done by distributing these funds than spent completely in a single project. Others argue that it is not necessary to build such machines since they do not offer direct benefits to mankind. We can clearly see the consequences of decisions already taken and the benefits we are today enjoying. Although these machines are very large projects which involve massive resources, their need is evident. Several accelerators have been built around the world, and each one has succeeded in their mission, except for one, the one that was never built. The Superconducting Super Collider, SSC for short, was planned to be the biggest particle accelerator of the world, even bigger than the actual LHC, but due to bad budgeting and $2 billion already invested, the project had to be cancelled in 1992. Leaving behind broken dreams for newly graduated physicists and an incomplete tunnel. This set the United States behind Europe in the scientific frontier, which it had held for decades. Nonetheless, the National Science Foundation, upon cancellation of the SSC, took an active role in the funding and construction of the LHC, sending both money and scientists, which ultimately resulted in the discovery of the Higgs boson, the God particle, a particle which reinforces our current view of the Standard Model. we see how this particular kind of machine is one of the biggest accomplishments of mankind, where nations, individuals, and ideologies coexist and cooperate to answer those questions that lie still in the dark, waiting for a light to be shone upon them.